Question 4 had 4 parts. We're asked to simplify some expressions that involve um, exponents, multiplication, division, and some negative exponents. And we've talked about the fact that at the end of the day, we don't want any giant ones lurking in our final answer. Um, we don't want separate factors of x or y or whatever spread all over the place, and we definitely don't want to leave the answer with negative exponents. So if I look at a first, I can see that it's clearly a monomial times a monomial. This is just multiplication here. And if I look numerically, I can see that the coefficient has this value of 2, and it also has a 3 squared. So if I was going to write out just that part first, right, when I multiply 2 times 3 squared, that's equivalent to 2 times 9, or the number 18. So we're going to start out with this 18, right? I guess I'll color code it. The 2 times 3 squared gives me 18. The next thing I see in this problem is that there is a single factor of x, that's x to the first power. And then I have 2 more factors of x, that's an xx. When I look at that together, I have exactly 3 factors of x, so I'll write that as x to the third power, x times x times x. And I'll color code that so you can see exactly where those come from. And then finally, I'm going to look at my factors of y. And you can see that I have, on the one hand, 4 factors of y, and then 5 more additional factors of y. So if I was to line all of those out, I'm multiplying exactly 9 factors of y times y times y times y times y times y times y. It's a lot of y's. So we'll go ahead and write y to the 9th power. And that's our answer, and we'll just go ahead and I'll copy that down right here. This is going to be 18, and then we'll have x to the third and y to the ninth. And it's completely fine if you change the order. By convention, we always like to have the numerical coefficient out front, but if you were to put 18 y to the ninth x cubed, that would be fine. And honestly, I didn't take off a point if you put x cubed times 18 times y to the ninth. It just looks a little silly, right? And I guess probably an unspoken rule is that if we have multiple variables, different bases, we kind of like to put them in alphabetical order. But there's nothing superior to this particular answer as long as you have an answer with an 18 and then x to the third and y to the ninth. So let's look at part B. Part B does have a negative exponent up in the numerator there, and I think most often what I saw people do is just pretend it wasn't negative and just deal with it like that. If I look at the 8 and the 32 in the bottom, I can see that there is a lurking 1. So I'm going to identify that first, right? My numerator has an 8. The denominator has a 4 times an 8. And then there's the x to the negative 2 and the x to the fourth power. So if I look at this, this is the value 1. I'm going to make this a little bit smaller. So there's a value of 1. So far what we're at is x to the negative second over 4x to the fourth. What I want to do now is neutralize this negative exponent. And to do that, remember, I'm going to hit this negative exponent in the numerator with the exact same positive exponent. So instead of x to the negative second, I'm going to multiply it by x to the second. Our thinking on this is that it turns out that that will give me x to the 0 power in the numerator, which is equivalent to the number 1. It is 1. Now, if I multiply by x to the second in the numerator, in order to make this a giant 1 and not change the value of our expression, I have to put x to the second in my denominator as well. So if you take a look at this, where we're at right now, the 8 is gone, so I just have x to the 0 in the top, and in my denominator I have a 4 and then x to the 6th power. And of course we've said it, x to the 0 power equals the number 1. So the answer that we should write down is a 1 in the numerator, and then in our denominator we should have 4 and then x to the 6th power. For part C, a over a to the negative 1 is not 1, right? There's something that we have to do to clean that up. And we could do this in 2 different parts. I guess let's isolate it. Let's look at this part first, and then we'll deal with the b's. So if I'm looking at this a over a to the negative 1. What I'm going to do is I'm going to multiply this denominator by a to the first, and then I have to put an a to the first up in the numerator as well. So this is just 1 that I'm multiplying by. Again, multiplication by 1 doesn't change anything. It's the multiplicative identity. In my numerator, I've got a to the second power, and down in my denominator, I have a to the 0 power, which is equal to 1. So where we're at so far is there's an a squared over 1 in my answer. Now let's go ahead and take a look at the b's. Let me get, so I'm not messing it up. I can't, so I can see what's going on. I'll use a different color for the b. So for my b, I'm just going to hit this denominator with b to the positive third, and then I'll hit the numerator with the same. Again, the reason why I selected b to the positive third is I'm trying to neutralize this negative exponent in my denominator. What I end up getting then in my denominator is b to the 0 power, which equals 1. And in the numerator, we've got b to the 8th power. So this just becomes b to the 8th over 1. So for my final answer, I'll just put those back together, and I'm going to have an a squared and then times a b to the 8th power. So a squared b to the 8th is c. And then finally for d, there's a couple different ways, honestly, you can go with this. There's only 2 of these, so I think it's pretty easy to go do this. Look, at this says I'm squaring 6x to the 4th. Just the definition of that means that I have 2 factors of 6x to the 4th. So I'm just going to rewrite this twice. 6x to the 4th times 6x to the 4th. Now that I've written it out like that, I can see that I have a 6 times a 6, which will produce the value 36. The other thing that I have is this x to the 4th times x to the 4th. And when I multiply x to the 4th times x to the 4th, I end up getting x to the 8th power. X to the 8th power. And you can see where all these things are coming from. So my final answer there is 36x to the 8th. And I'll write it over here in red. 36x to the 8th power. All right, that's it for 4.